If you want to understand how enterprises use Agentic AI, how they react and process to data in real time, you need to understand Kafka. Kafka is the backbone of event-driven architecture. It streams millions of events per second and gives AI agent continuous stream of facts so they can react and adapt instantly. Hello, I'm Alexander Harikov. I work with integration for many years, and today we're going to talk about Kafka's architecture. Apache Kafka is a distributed event streaming platform. Instead of pushing messages directly from one application to another, Kafka stores events in a durable, append-only log, and applications consume these events at their own pace. This design enables scalability, repeatability, and extreme durability, fault-tolerant and real-time streaming. Everything in Kafka exists to support these capabilities. And this is what we're going to break down now. So, core Kafka components. Number 1. Brokers. A broker is a Kafka server. A Kafka cluster is made up of multiple brokers working together. Each broker stores data, serves client requests, and manages partitions assigned to it. When clients produce or consume data, they are communicating with brokers, not with a single centralized node. If one broker fails, the others continue running. That is the key architectural idea: distributed responsibility. No single broker needs to handle everything, and that's what lets Kafka scale as you add more machines. Number 2. Topics. A topic is a logical category or stream of events. Think of it as a named pipeline. Producers write events into a topic. Consumers subscribe to that topic and read events from it. A single topic might represent something like orders or management system, payments, sensor readings, or user activity. The important thing about topics is that they are not executing any logic or deliver messages to consumers. Topics simply store events, and Kafka leaves the consumption model flexible by design. Number 3. Partitions. Inside each topic, data is split into partitions. A partition is an ordered, append-only log. Partitions helps with scalability and parallelism. Within a partition, events are strictly ordered. But across partitions, Kafka does not guarantee strict global ordering. And that's by design, that's intentional, because strict global ordering would destroy throughput. So when we are talking about Kafka's performance or consumer scaling, we are really talking about partitions design. Number 4. Messages and offsets. Every event written into a partition becomes a message, and each message is assigned a unique offset, an incremental position in that partition. Offsets are crucial because Kafka itself does not track what was processed. Instead, consumers track their own offset. That means that consumer can pause, restart, replay from an older offset, or skip forward. As a result, we have a very powerful behavior, reprocessing as a built-in technology. That is a major difference between traditional message queues. Number 5. Producers. Producers are applications that send data into Kafka topics. They decide which partition a message goes to. To make a decision like that, they use key-based strategy or round-robin distribution for load balancing. Producers can also control delivery guarantees. They may use fire and forget, wait for a leader acknowledgement, or wait for full replication acknowledgement. That tuning allows systems to choose between latency, durability, or throughput depending on the use case. Number 6. Consumers and consumer groups. Consumers read messages from topics. Consider consumer groups as a logical grouping of consumers subscribing to the same topic. sharing processing load. The problem with having only one consumer is that as we increase the number of partitions and produce more messages, the consumer starts getting overwhelmed, and that decreases performance. And to achieve parallel consumption and automatic failover, we add in groups to our consumers. Kafka is not just technically elegant, it enables a fundamental switch towards event-driven architecture. Instead of services calling each other synchronously, systems publish events to topics. Other systems react to those events in real time without tight coupling. Now let's extend this to Agentic AI. AI agents operate in real-time environments, autonomous decision engines, operational copilots, anomaly detection. None of these can operate without real-time data. They need continuous real-time context. Kafka provides that stream of events, live transactions, telemetry, user actions, or system signals. And AI agents, on the other hand, observe stream of events, detect patterns, and respond immediately. Kafka essentially becomes the nervous systems for intelligent, event-aware applications, allowing AI and AI agent respond to the latest state of the world, not just yesterday's snapshot. So that is Kafka's architecture. It is built around brokers, partitions, producers, consumers, consumer groups, offset, replications, and topics. Kafka is a foundation for event-driven systems and real-time intelligent agents. Thank you for being with me today. Please give a like to that video, subscribe to my channel, and watch my other videos. And see you next time. Bye!